Howdy! This is your friendly neighborhood physics teacher here, and this is your first test review. Dun 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 dun! So your test is on Friday, and don't forget that the review will help you on your test because it goes over the major points that the test will talk about, and 2, it's 10 points. That is a full letter grade. So you better be doing this review. Now, another thing, if you haven't even started the review, pause the video. Pause it. Don't you continue. Because one, you just watching me do the review isn't going to help you. Because guess what? You don't get to watch me do your test while you fill in the test questions. That's not how this life works. So please attempt the review before watching this, and then watch it, and you can make sure you're doing it right. And if there's anything you need to add or something, you can add to it. Your review needs to be turned in right before the test. None of this, I'll get it to you later. Nah. That doesn't work. Not for the reviews. We do remasteries on everything else but the reviews. The reviews, you need it right then. 10 extra points. Now, let's say you do half of it, we'll give you 5 points. You do a little bit less, we'll give you 2 points. Do a little bit more, we'll give you 8 points. But to get the full 10, you have to do all the questions. So without further ado, let's dive into the life of safety lab procedures, metric conversions, and dimensional analysis. So with the safety lab rules, so those are in your chicken. Those are the 15 rules. There are also posters around your classroom. And guess what? Those posters are going to stay up. So, if we forget what a rule is, maybe we can look around the classroom and see if we can find a rule. But I would say the rule to focus on, there's one good rule to focus on, and maybe that's the no eating and drinking rule. I'm feeling like that's a rule to make sure we understand. Just maybe. You never know. And then memorizing the metric stairwell. The metric stairwell will not be given to you on your exam. What will be given to you is your conversion chart. So it's that nice one that has all kinds of stuff. So it goes from your American linear units, American to metric units, American capacity, weight and mass, converting American units, then time, metric to American units, temperature, stones, medical applications, all that fun stuff. That's the one you'll be given digitally on the exam. But look right in the middle. Look right there. What do you see? Metric units. So maybe secretively we're going to give you the stairwell, just not in stairwell method. The one thing that's definitely not on there is exponents. But we put base, your conversion chart says unit. So as long as you know that base and unit are the same thing, you're golden. So that one's 0. So going to y'all's left would go to 1, 2, 3, skip to 6. And the one that doesn't have there, giga is not part of that. So don't forget to skip 2 and go to giga. Then you go to deci, which is -1, centi, -2, milli, -3, skip 2, go to micro, which is -6, and then you skip 2 and go to nano, which is -9. Again, giga and nano are not on that list. So those would be the 2 you need to memorize. Everything else is right there for you. It even says going to larger numbers to smaller numbers, move the decimal to the right. Going from smaller number to larger unit, move the decimal to the left. So it even kind of helps you where to move the decimal. That will be given to you on the test. Another good way to do extra practice problems, you can look at your past homeworks. You can even do the remastery. It won't hurt you. It can only help you. You can look at past entrance tickets. They should all be open and anything like that. And then, of course, you have your mixed calculations. If you have any questions over anything, please ask Miss Heath or Miss Verona. They would love to help you. They really do enjoy their jobs, and they feel needed when you ask them questions. Just an FYI. But let's get on to some important information here. So understanding questions, so you need to understand the answers to the questions below. So what is a theory? So theory, it is a law. but it's a law that can be corrected or overthrown. Overthrown. So it's a law that can be corrected or overthrown. So like a theory of like the Big Bang Theory. So as of right now, all of our data points that the Big Bang Theory happened. But if there's another thing that comes through and disproves that theory, it can all of a sudden be thrown out. But the law of gravity, that is a full out, non-negotiable law. Is there everything, nothing that is poof. You drop something, it's gonna fall. There's no ands, ifs, or buts. But yeah, so theories, it is law. It's what we perceive to be as correct, but it's kind of like a that's right. Like, as you say, going up because it's a question mark until someone goes, no, it's wrong, and throws bad evidence or correct evidence at you to overthrow it. So that's kind of like what a theory is. So a hypothesis. A hypothesis has to be testable. So it's a testable statement. It's a testable statement. That's what a hypothesis is. So I can say, if I drop this pencil, if I drop this pencil, then it would fall to the ground. I can test that. I can pick up a pencil, I can drop it and see what happens. That is testable. I can't say something but a hypothesis for me might be different from a hypothesis for like a true scientist. I can say, if I throw something at the moon, it will get to the moon, and it's, for me, I can sort of test that, but that's not reasonable. But like NASA could throw something at the moon and actually see what happens. So it's a hypothesis that's testable to the person that's saying it. Now, accuracy. Accuracy, we talked a little bit in class. And accuracy means, like, if you go to like the dart, accuracy means you're hitting right on the money. You're perfectly correct. Precision means you're really close together. So you're constantly like pulling to the right, but all your darts are in that little area. Now, you can be accurate and precise. It is possible to be accurate and precise, and that's when you're doing several little things. Give me back my dot. There we go. So you're doing a lot of things and you're hitting it on the money right there. So you can be accurate and precise. Now, you can be precise but not accurate. That's kind of this one right here. This one, let me get a different color here. So this one is precise but not accurate. This one is accurate but not precise. This one is both. So that one's both. So there we go. So the best graph to use when you are comparing something to time, that one is a line graph. Whoop, need to write. There we go. So that is a line graph. When we start getting into 1D motion, you'll see that we have like position versus time. And we use line graphs for those. Or velocity versus time. So most of the time in physics, you'll be using line graphs. You will not be using pi or bar or anything like that. The graphs we like are line. So what unit metric base is used for mass? Let's get a different color here. What would be a good color to pick? Let's do, how about we do a little bit of light blue? So that would be your grams. For mass, we use grams. Now, that's your base unit. In physics, most everything is in kilograms, but base unit would just be grams. For measuring length is meters. And that's actually the same thing for physics. We use meters for everything. For volume, that will be liters. And if we do have to measure something volume-wise, we tend to use milliliters. But yeah, so there we go. Those are just your three main bases. Conversion time. Dun, 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 dun. Getting into the real good stuff here. So we need to convert decameters to kilometers. Now that's not a dam. It's not something that a fish runs into and says a bad word about. Or something you say when you stump your toe or something like that. That is decameters. There's a couple of different ways to do this. I'll do them both. So if I'm doing both, I need to give myself some space. Maybe give myself some space, possibly. Nope. It's not gonna work. Just killing time here for a second. Space. So I can do both for y'all. Space. So how y'all doing? As your crazy physics teachers just messing around, wasting time, trying to give herself some space. Okay, there we go. So you can do the exponent method, or you can do the jumping method. So I'm gonna do the exponent method first because that's what I'm most comfortable with. Just because I like it doesn't mean you gotta like it. It's okay to do the jumping method, but I like the exponent method. So if you're looking at your conversion chart, deca is right to the left of your base. So that means your exponent for it is 1. Helps if I actually get my thing to write. 1. You always subtract. Kilo is 3 to the left, so your exponent for that is 3. 1 minus 3 gives you a, what? Yeah, -2. If you need your calculator, you can pull out your calculator, plug in 1 minus 3 to get -2, that's fine. So that's how many times you're going to move. The 2 tells you times of movement. And your negative tells you direction. So that's telling you you're moving to the left. Negative means left. So we're going to zoom in real quick. And we're going to start here. So if you do not see your decimal, it's always right behind your number. And we need to move 2 to the left. So we're going to move it 1, 2. So that means it is 40.36 kilometers. That is our answer. There we go. We're done. Now that is in standard form. To put it in scientific form, let's get another color out here. To put it in scientific form, we need to move it over one more time. So that becomes 4.03, oh, we can round it up, 4, getting fancy, times 10 to the, and we moved it once, and our number is bigger, so it's a positive 1. So we have 2 answers. That is our answer in standard form. This is our answer in scientific form. And that's using the exponent method. If we're using the jumping method, that's when you can use your conversion chart, and you have, so you would have giga, space, mega, space, kilo, hecka, deca, and then of course you'd have base. Then you have deci, centi, milli, space, move it over, micro, space, nano. And we see where we're starting at. So we're starting at deca. So we're starting right here. We're trying to get to kilo, so we're trying to get to here. So that's going to be a 1, 2 jump to the left. So again, you do the exact same thing. You move it over 2, you have your standard form, you got to move it over again to get your scientific. So either way, exponent or jumping works just fine. So let's look at the next one. So our next one is micro to centi. Micro is down here over here. So micro is right here. Centi is right here. So again, that's going to be a 1, 2 jump to the left. So we're going to zoom in, and we're going to jump 1, 2 to the left. So it'd be a 0.07, round that up to 7 centigrams. So there we go. So that is our answer. That is our answer in standard form. If we were going to put it into scientific notation, we would need to move the decimal back 2 times. So it'd be 7.70 times 10 to then we moved it twice, but it's a small number. It's smaller than 1, so it'd be a -2 centigrams. So that's our answer in scientific notation. That is our answer in standard. There we go, using the jumping method. If you want to use the exponent method, micro is -6 minus our centi, which is -2. We have a -6 minus a -2. That becomes a plus. So you get a -4. So that 4 means yep. See? Whoa! I told you I'm not very good at jumping method. I told y'all I'm not very good at the jumping method. It's okay. I accept my mistakes. It's okay to make a mistake. It's okay to make a mistake. And I'm sure y'all watching are screaming like, no, wait, you're doing it wrong. And I was. And I do apologize about that. But everyone's going to learn from each other's mistakes. So let's try that again. So if we're going from micro to centi, we have to do 1, 2, 3, 4 jumps. You cannot forget about your skips. Can't forget about these. These you cannot forget about. They're very important. Don't forget about these. Don't forget about that one. Don't forget about that one. Don't forget about that one. And then the 2 over there, don't forget about. Because that's just what happens when you forget about them. You make a mistake. And it's okay. We are human. It's okay to make a mistake. So we're going to backtrack. So we're supposed to jump it 4 times. Let's try that again. 1, 2, 3, 4. So that becomes a 0.1234. 1, 2, 3, 4, 7, 6, 9, 3. There we go. And that is in centigrams. And that is now our standard form. Now we need to move the decimal over 1, 2, 3, 4, 5 to get it into scientific. So it'd be 7.69 times 10 to the -5. That is our answer, centigrams. Ooh, nope, go away. Thank you. Centigrams. I do apologize about that. But hey, we're going to pretend I planned that. See, it's okay to make mistakes. Miss Heath's always telling you it's okay to make mistakes. See, it's okay to make mistakes. Everyone's human. We'll just go on that tiny little rant there. So then we have a negative. So again, going back to the exponent, micro is -6 minus -2. That becomes a plus. So that becomes a -4. Again, you jump 4 times. You have to jump 5 times. And you get the exact same answer. I do apologize about that, but it's a good learning moment. Everyone makes mistakes. Now we got to convert nano to giga. That is a huge, huge jump. So if we're doing exponents, we have a -9 minus a +9. That's a 9, I promise. There we go. -9 minus a 9. So -9 minus 9 will give you you add that up, so you get a -19. So a -19. So that means you got to do 19 jumps to the left. 19 jumps to the left. Whew. Now, if you don't want to sit there and do 19 jumps, there is a way around it. You can just put the 34.567 times 10 to the -19. You can do that. And then you will, and then to get that, it's almost in scientific notation, right? it's almost in scientific notation, so you just have to move the decimal over one more. And since you're going from a bigger number to a smaller number, you're just going to add 1. Add 1. So you get 33.46 times 10 to the negative 17. And that is in gigaliters. So there we go. So we've converted into gigaliters for you. Now you can sit there and do the jumping and all that fun stuff, and it should work. So I believe that's all our metric conversion problems. We are going into our dimensional analysis. So going into dimensional analysis, I like using the railroad tracks. So we're using the railroad tracks. That's right. So you put what you're given on top. You're given the 6, 2, 9, 3, 8, 4, and that is in inches. And we're trying to get to miles. So that's when your handy-dandy conversion charts comes into play. So if you can go to inches to miles, let's see here, inches to miles, there is a conversion chart for that. So you do 6,360 inches to 1 mile. So you just take the top, divide that by the bottom, and you get your answer. Calculator needs to work. Here we go. So we're going to 629,384 divided by 63360. And you get give me a second. There we go. And you get a 9.93 miles. And it's actually kind of in scientific notation already, because it would just be 9.93 times 10 to the 0 miles. So there we go. You've converted. You're done. So now the next one. The next one's a little trickier because we're going from meters per second to miles per hour. So anytime you see the MPH, that is miles per hour. So you write down what you're given. You're given 45.67, and that's meters per second. And we're converting it to, now you're converting your meters to miles. If you look in your conversion chart, you can't go straight from meters to miles. Now you can go from meters to yards, meters to feet, meters to inches, then any 3 of those to miles. So let's do feet. So meters goes to the bottom, and we're going to convert it into feet. So for 1 meter is 3.281 feet. Our meters cancel out, and we're left with feet. But we don't want feet, we want miles. So feet to miles. If we look at feet to miles, there are 5, am I looking at it right? Yes. So 5,280 feet to 1 mile. Now we finally got feet to miles. But we got to keep going because we need seconds. We need seconds to hours. So seconds is on bottom. So seconds need to go on top to cancel. And then we can convert to hours. In your conversion chart, it's there. You have 3,600 seconds for 1 hour. Now you just multiply across the top, multiply across the bottom, and divide. Multiply across the top, multiply across the bottom, and divide. You do that with your handy dandy calculator. Times 3.231 divided by, whoops, nope, there we go, and multiply by 333, and you get 102.17 if you round or so. And that is now officially your miles per hour. There you go. So about 3 more problems to do. And the next 3 are word problems. So Jacob and Samuel are racing boats. Now these are the 2 twins, if you're just wondering. So Samuel's boat went 20 meters. Jacob's boat went 40,000 millimeters. Whose boat went farthest and by how much? And we want the answer to be in meters. So luckily enough, Samuel's boat's already in meters. So we don't have to worry about converting that one. But Jacob's boat, come on, Jacob, what you doing measuring in millimeters? You know better. Miss Verona will get on to you. And so yeah, so now we need to convert that millimeters into meters. So to do that, again, if we're kind of looking at the exponent method, millimeters is -3. And then meters is 0 because it is a base. So yeah, so we're going to do a -3. Why aren't you writing? There we go. So we're going to do a -3 minus 0. So that gives you -3. We're going to move it 3 times to the left. So 3 times, so decimal starts there, and move it 3 times to the left. 1, 2, 3. So we get crunch. So we get that we have 20. Ooh, right. Come on, dude. So we have 20 meters from Samuel's. We have 40 meters from Jacob. So whose boat went the furthest? Dun, 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 dun. Jacob did, even though he measured in millimeters. It's okay. We forgive him for at least he went the furthest. And by how much? Well, that's easy. You just subtract 40 minus 20 gives you 20. So he went 20 meters more. So he just went 20 meters more. Now, for the next word problem, Miss Heath is thinking about buying a seed from the Century Tree at Texas A&M. Century Tree is 13.72 meters tall oak tree. Oak trees grow about 0.55 millimeters a year. How tall was the Century Tree 10 years ago? And we want the answer in meters. So again, it's kind of very similar to the Jacob and Samuel problem. We need to get that millimeters into meters. So again, so we know we're going to, so this time we can kind of let's do the jumping method on this one. So we're going from millimeters to meters. So we can just stay, so we have giga, skip, sip, mega, skip, kilo, hecka, deca, base. That should be a B, not a D. Let's try that again, shall we? Base, deci, centi, milli, skip, micro, skip, nano. But we just need milli right now. So we're at milli, and we need to get to the base, which is meters. And we're going to skip 1, 2, 3 times. So that means we're moving it 3 to the left. If we scroll in our number here, we're going to move it 3 to the left. So 1, 2, 3. So our number becomes 0, 0, 0, 5, 5 meters. Now, if the tree is 13.73 meters tall at this point in time, and we want to know how tall it was a year ago, what do we need to do with those 2 numbers? Hopefully you said subtract. Hopefully you said subtract. So we're going to take that 13.72 and subtract that 0.00055, And that's going to give you a really small number, or not a small number, but not a big difference number. So it didn't grow very much in a year. Not at all. So it becomes 13.71 meters. So it didn't grow very much at all. Oak trees grow really, really small. And Miss Heath really is thinking about getting a seed or a seedling from the oak tree, but she doesn't necessarily want to plant it where, she doesn't know exactly where to plant it because it's going to take forever to grow. So that's what her dilemma is there for getting the century tree. And if you want to know her story with the century tree, just ask her if you're romance. If you don't like romance, don't ask because it's a gooshy story. But it's really cute, so you should ask her. That's okay. So now, the next one. This one is just a good old practice. Can I do dimensional analysis random question? So Miss Heath goes to Texas A&M games in her painted overalls, which she does. And hopefully she'll wear her overalls one day so y'all can see them. So how many whoops will she receive? And the trivia is what numbers go with what. So yeah, so let's think about this. How many overalls can Miss Heath wear to the game? Hopefully you just said one. So she can wear one. And I'm just going to put PO for painted overalls. Now, on our conversion chart, it says that 5 painted overalls gives you 2011 gigams. So we can put 5 painted overalls and 2011 gigams. Then it says that 1118 gigams give you 1999 sols off. So that cancels. So gigams go below to do gigams to get, sols off. I'm going to make it smaller. There we go. So the gigams cancel. And then to get 417 sols off gives you 1871 reveilles. So our sols off cancel. And then we get 68,603 reveilles to 12 whoops. So all we're trying to get to on this problem is it doesn't matter what the units are. Is you have to have a unit on top and a unit on bottom to cancel out. So as long as you can do that, now you just multiply across the top, multiply across the bottom, and you can get your answer. And that's going to take your friendly neighborhood physics teacher a while to do that. So please be patient with her. She'll sing you while she's doing this, because she's a nut, but you love her anyway. Make sure she actually did it right. Yes, she did. Okay, so your answer is she will only get, it's not very many whoops, she'll only get 0.56 whoops. So not even a full whoop. Sad day. So there we go. Now, the trivia says, what do these numbers mean? The 5 on the 5 painted overalls is Texas A&M has 5 yell leaders. The 2011 in gigams is the year Miss Heath graduated. The 11, 18, 1999, that whole entire row is a year. That's the year that the bonfire fell. So that's a very important year for Texas A&M. 4/17, 1871 was the date Texas A&M was officially a university. 68,603 are the number of students it has at this point in time. And then 12, of course, 12 is the big the 12th man. 12 is a very important number to Texas A&M. And yes, maybe I'm trying to brainwash you to like Texas A&M. You never know. So hopefully that helps. If you have any other questions, remember you can ask Miss Heath or Miss Verona. Again, they love answering questions. Hope you have a wonderful day. Bye.